Hi, everyone. Welcome to today's session. I'm going to introduce Mesut, who's speaking about the futures today. He's an experienced quality assurance QA testing software engineer, and he's going to be talking about how machine learning is actually implemented in the software supply chain, in the testing cycle. So, Mesut, introduce yourself there, and we're super excited.
Thank you so much, Nigel. Yeah. So if I have my
Yes,
slides on the screen,
I,
yes.
I will add it to the stage.
Okay, cool. Thank you so much. So again, let me briefly introduce myself. My name is Mesut Durukal, and I'm a software assurance, quality assurance automation engineer. So I'm basically doing the test automation. And today, of course, we will talk about test automation, but from a different perspective, like using machine learning in software testing. Because in software testing, we have several stages. Like we have different activities. Some of them are related to the defining the test cases. Most of the time, we are working on automating, implementing the test code. So, and sometimes it is just managing the bugs, the issues we have. So all these are different parts of software testing and the quality assurance activities, verification and validation activities. And in each of them, somehow we can use machine learning. So today we will discuss about this, how we can use them, or what kind of, maybe I will share some tools as well. So this is not marketing any of them, promoting any of them, but just give some ideas about the usage of them. And not only the tools, but also I will share some ideas, approaches to use machine learning. For example, I will share one practical example as well, which I applied in my project. So what I will do is I will start with, first of all, let's discuss the need and the background. Like, first of all, why are we talking about using machine learning in software testing? What's the relevance? Why is it needed? What's the requirement for that? And then after this problem statement and why are we doing this, we will discuss about different ways to use machine learning in software testing. And eventually in the third part, this is what I was just explaining, I will share you with a case study where I did classification of the bugs in my project. For example, in all projects, we are reporting some bugs, right? We have bug reports. And of course, we have the description, the title of the bug, and we assign to some people. But one very important thing is we assign the severity levels or the priority levels. Like some bugs are critical severity levels, some of them are less criticality or the severity levels. So I did this classification. Like whenever we have a new bug description, then based on this description, based on this text, it will be something like NLP, the natural language processing, and try to guess what uh, priority level or the severity level it should be based on the previous experiences, the previous learnings. So this is why we call it machine learning, right? So we will discuss all these stages one by one, and let's get started with the first one, the introduction part, which is why are we talking about using machine learning in software testing. Machine learning is already very hot topic, right? It is everywhere. Like it is in my smartphone, it is in my smart TV, all the electronic devices, even in IoT devices that we are having, collecting data everywhere. And of course, whenever we have data, we can do some analysis on that. But once we are talking about software testing, again, of course, as I already explained, bugs are already a huge data source for us. For example, we can already analyze from what kind of aspects we are having some issues, weaknesses before going production. So this kind of thing analysis we can do. Not only that, but also we can improve our efforts, and maybe we can reduce the time we are spending on these activities, right? Because we have too many challenges. Software testing nowadays is not easy. The systems that we are testing are really very complex and complicated. We have too many integrations. It is not only just desktop application, right? We are generally deploying to different platforms, and those applications are talking, communicating to other applications too, because sometimes there are some APIs. One application is sending some requests to another one and getting some responses from some other servers and showing on our dashboards or the charts on our application. This means there are too many integrations and interfaces. So whenever we are developing our application, we have to ensure the quality, or we have to test all these interfaces, integrations, and executions on different platforms. For example, if it is a web application, we are not testing on a specific browser, but we are trying to do a compatibility testing, right? We are executing a lot of platforms on a lot of environments. So this means software testing really needs some effort and comprehensive planning and efficient working. Time is very precious. There is of course the time pressure. The testing windows are very limited. Sometimes we have only a couple of days before going production, before the deployment. We have to understand if there's a critical issue or not. So if you cannot catch these kind of issues, critical issues, before going, then maybe the customers will see those kind of issues in production environment. So it's a critical process, which means it feels a little bit stressful, right? There is too many challenges: the time pressure, the comprehensive scope, the difficulty of automation, everything. These kind of challenges, sometimes we might feel desperate. Too many difficulties, too limited resources, not too many people, not too many headcount, not too much time. So it might feel desperate, but these kind of difficulties and challenges encourage us to find some new solutions, some new integrations. So one idea is maybe we might get some help from the machines, right? If we have too many challenges, why don't we collaborate with machines as human beings? Can they help us? Actually, they are already helping us in a lot of different ways in our daily life, right? As we discussed in the very beginning of the presentation, like whatever we are doing, sometimes, even if we are aware or not, we already can encounter machine learning algorithms in lots of places in our daily lives. For example, whenever I'm reading an article, the system is already recommending me some similar articles, or maybe some other articles that I might be interested in. How does he know? Most of the time it's very accurate, right? How does it know? Because it observes my interests. It knows my previous patterns. So it learns who I am, on what I might be interested in, or on what I'm working. So it knows my patterns, my interest, and my inputs and outputs, these kind of relations. So it basically observes and learns. These are the training data for the machine. And then after the model is generated for me, like it will be a Mesut model for me. So on top of what kind of inputs, I can generate what kind of outputs. So this is the model. So the main mentality is like just observing, getting a lot of data. So training data is very important, and then trying to predict the upcoming reactions to these kind of incoming data. So we will see it will work in a very similar fashion for the software testing. I'll come to that point. But for now, we can just accept that machines are already helping us in lots of different ways. So why not in software testing too? They can also help us to implement or to conduct our verification and validation activities. So actually, my title of this presentation was Future of Software Testing when I started presenting this topic a few years back. But now I'm not presenting this anymore as a future of software testing, because it is not the future anymore. We are already there, right? We can easily use a lot of machine learning algorithms in seconds. It's very easy. There are some cloud platforms, as we all know. We can just ask some queries and get very accurate answers in very short times. For example, I'm sharing this movie. It is the Minority Report movie. I think it was almost 20 years ago released. And when I first saw it, it's it was just a fiction, right? It's science fiction. So who believes that? Like it is just imaginary. But now we are almost there. For example, like the machine learning algorithms can be used in lots of different areas and industries, in law as well. Like in that movie, the criminals were being predicted before they even commit these crimes. So again, we can see that some, of course, not the same usage, but in lots of different ways, in law, in medical care, in IT, in cybersecurity, manufacturing, in lots of different places, we can see machine learning can be utilized. So this is just as a general introduction. So I will focus more on the software testing too when we will come to that point. But again, uh, for example, we all, I believe, we all use in different ways ChatGPT or some other platforms to perform our queries, right? For example, even if I ask some similar questions, some related questions, like what kind of tools I can see in software testing industry, it can list a lot of different things to me. So not only the tools, but of course, even if I describe a problem, then it can understand on top of the previous experiments, the previous observations, and it can generate some solutions. And most of the time it's very accurate. So let's a little bit quickly remember the working mentality and the idea of machine learning again. So again, we collect the training data and we build our model and we start evaluating the performance. So if we are satisfied with the performance, then we can already deploy. But otherwise, if we feel like we can further improve our accuracy of our model, then we can again maybe modify or do the fine tuning with the arguments or the maybe other options of the model, and we can try to achieve the best performing configuration. So this is the very basic background. And again, the learning mechanism is very similar to what happens in our biological organisms. For example, we as human beings, we also collect and several, we have interceptions, right? We have several integrations or interactions with the outer system, and we collect this data. These are the learnings for us. For example, let's talk about a concrete example. As a software tester, you might ask me to test your system, which is, let's say, an online sales system, right? You have a web application over where I can navigate to your system and choose some items, add into my shopping basket, shopping cart, and then approve my order. So the delivery will start after the payment. So this is a very simple online payment system or online shopping system. So if you ask me to test your system, I can do that, right? I can predict more or less what I have to do. Like I have to select some items and I should add them into the basket. And then I can view inside the basket to see what kind of items there are. And I can maybe add even more or remove some of them, modify my basket, and then go to the payment system. So I can predict that. But this is the first time that I'm using your system, right? So how can I know that? Of course, thanks to my previous learnings, previous observations. Oh, I did not use your system before, but of course I used some different systems which is working in a similar way. So if they have those kind of systems, maybe I can predict that in your system, more or less, there will be some scenarios which is having those steps, like uh, modifying the basket, like adding some items or removing them, and then confirming that and go to the payment system. So this is my prediction. But of course, I have to see it. It will be an exploratory testing way. So in that regard, the machine learning algorithms will work in a very similar fashion that our biological learning happens. So first observations, do some modelings, and then eventually, whenever we have a new system, whenever we have a new upcoming input, we will make our predictions. So this is very basically how it works. So, after this introduction, let's a little bit talk about how we can use machine learning in software testing. What we can do by means of machine learning. Let's see what we can do. So, in software testing, we can start by analyzing the requirements, right? First of all, we have to understand the system. And then, after doing this analysis, we have to design our test cases to cover the requirements. So, this is the traceability between specifications, requirements, and the test cases. And after we do this planning, after we do this test design, we have to execute the test cases that we designed, we developed. How we execute? It can be either in automated ways or in manual ways, right? If we are doing the automated test execution, then first of all, of course, we have to implement the code, which can be automatically executed. And then after the implementation done, we can just start the execution. Or if it is the manual test execution, after the steps are ready, we can just start executing them. And after the test execution is done, the final stage is the maintenance, the test cycle closure, which can be by maybe raising some issues, opening some bug tickets, or maybe it might be some refactoring algorithms, refactoring activities on our test code, because test code might be flaky, right? Sometimes there might be some issues on the test code that we developed. So we might need to fix them, to refactor them. So it is a part of the maintenance activities that we can do in the last stage. So for all these stages, I will show how we can use machine learning. Let's start from the beginning. The first is we analyze the requirements. So we should design or define some test cases, test case definition stage, the very first one. So for that, again, I will start with an example. I guess it will be easier to understand over a concrete example. So on this example, I have an API query, which is basically, it might be, I guess, a library API. So you have a application for your library. So the users can query the books inside, the available books they can rent, or maybe they can, as the admin user, they can add some new books by performing a post or put query. So this is the how the entities looks like. For example, in each book entity, we have the ISBN number uh, represented in a ISBN field, and then there's the price attribute of the book entity, and then there is the year, which states on which year the book was published. So these are the basic attributes or the features of the book entity or the book object. So what we can see here is, by a simple observation, I already know the attributes of a book. When I'm talking a book, like an object, which is a book for me, it should consist these three attributes, at least by observing this. And not only that, but also the format of this data. I can already see how they should look like. For example, ISBN has a special format, like first there's a digit, and then there is the dash hyphen, and then there are some three more digits, and going on like that. There's a special format, like probably it's a standard for uh, expressing the ISBN numbers. And when coming to the price, I can see that there's probably a double value. And for the year, it is probably a positive integer, right? The year probably, theoretically, it might be a minus value too, but in our case, if we are building a library, probably it will be, the year will be something, some positive values, right? So these are the things that I can already observe, and I can model my data and my system. So at this point, what I can do is I can already generate some test data. For example, since I know what attributes I have to include in this entities, and I know what kind of data I should include, I can already generate some random values by injecting different numbers or values. And intentionally, I can inject some negative scenarios as well. For example, whenever a string with a special format is expected in ISBN number, what if I pass it and with an empty string, for example? If it's a mandatory field, what happens if I pass just an empty string? So this might be a negative scenario. So all these kind of observations, and on top of those expectations, I can already do some injections, and I can generate some test data. So generating the data itself is one step, and then generating the test steps, step by step test definition, is another step. So on that regard, of course, like when we talk about using machine learning, it is coming to a point like almost like equal to using ChatGPT. But of course, it is not only ChatGPT, but we can develop our custom approach as well, right? Because most of the time, okay, ChatGPT is very convenient, but most of the time we have some security concerns. Like if I'm conducting some company activities, of course I cannot share everything to ChatGPT. So there might be some sensitive information, so I cannot send everything. So which means I can somehow develop my own custom approach as well, my custom machine learning algorithm too. But this is again just to give you an idea what in what ways we can use machine learning. So I'm just going over some different ideas. So generating the test steps, doing step-by-step test definition by using machine learning is another option that we might utilize. What else? After we define the test cases, developing the test code is the next step, right? And how we can develop our test code? First of all, we might figure out what kind of operations we need in our algorithm. We will have a problem and we need a solution, right? To going to this solution from the problem, for this purpose, what kind of algorithms I need, or operations, mathematical operations, or some other operations I need. To figure out this, we can again utilize the input output relationship of our model. For example, I have one example on this slide. I have an input, and by applying some mathematical operations, I have to get this expected output. So, what kind of mathematical operations I can do? For us, it might be a little bit tricky to immediately figure out. Maybe some of you already figured out, but it is not easy to understand immediately. But for machines, it is not that much a big deal. So the expected algorithms in this case are all the input values are multiplied by 4. For example, I have minus 17 at the beginning of the array. So when I multiply by 4, I have minus 68 here. So all the values are multiplied by 4. Multiplication is the first algorithm I need. And then I can see only the negative values in the output, right? Normally there are the negative values and the positive values, but the positive values are filtered out. So filtering out is the second algorithm I need, operation I need. And then I need a sorting operation too, like starting from biggest to smallest. Those are ordered, sorted in this array. So this kind of like multiplication, filtering out, sorting, these kind of operations are the things that I need to build my algorithm. So after figuring out this, the applying the relevant code is not the difficult part, because whenever I figured out that I need a multiplication operation, it is just a very simple function, right? Just taking an input and returning by multiplying it by 4. So that is not the difficult part. The real challenge was figuring out the steps or the operations that I need to build my algorithm. So again, one example is, I guess it's a commercial one, but it is developed by Microsoft DeepCoder. It is using this approach, and you can investigate more to see how it works. And of course, again, another approach is just doing the NLP, just asking your steps. Like in my application, I have to go to this URL, navigate to this URL, and select this locator, or like some elements on the page, type some inputs, and click some buttons. So just describe your problem, and you will have the code that you can use. Most of the time, of course, it gives you a code you can use. Sometimes, of course, you cannot just copy paste, but very slightly modifying the code, you can use it. So this is just a way to get some ideas. So even if you might have to modify some piece of the code, you might already get some idea about in what way you can implement your code. This is open AI example. And again, from another family, from the same family, another example is the chat gpt, where when you ask your problem, like describe your steps, log into this application, do the steps, and eventually do this assertion, do this verification, then it will let you know the relevant code. For example, here, I guess this one is a, yeah, CY is a Cypress code. So in this example, I'm sharing a very specific, like give me a solution which can work in Cypress test automation framework. But you can change the framework, like you can ask for a playwright solution too. You can ask for Selenium code too. So not depending on the language or the framework you are using, it will generate the code that you need. Moving on, another example is you can even turn the API queries that you do over Postman. So first of all, you have some queries on Postman, which is mostly done to do the API testing. And then after doing this doing these queries, you can convert the relevant query to a curl command. And even the curl command, you can convert to different programming languages. Like if you use JavaScript, you can convert to a fetch query, or if you are using Java, you can use some other libraries like HTTP request or something else. So these are most the test automation or the implementation steps where you can somehow use machine learning in different ways. Like most of the time, it can be a natural language processing. Like you can ask your problem in the natural language that we use in daily life and get the response, or in some other ways too. And again, just as a reference, I'm sharing too many tools that you can see in the software testing industry in the marketplace. Again, some of them are, I guess, in this one, some of them are open repository, but some of them are commercial ones. Just to give you an idea, you can just go and see what kind of approaches they utilize to build their models. But I wanted to share this because, especially for UI automation, I feel like machine learning is very important, because normally, traditionally, how we do our UI automation is we need some locators, we need some selectors, right? Because what we are doing when we are doing the manual testing is we just select some elements or do some interaction with the elements. But what does it mean in terms of coding? Like whenever I click a button, what does it mean? For example, the very early, very primitive test automation frameworks were working on coordinate system. Like, for example, on what spot you are clicking, it was checking the coordinates of the window. But of course, it doesn't work anymore, right? Because whenever you minimize your window or increase the size, then this is not the same coordinate anymore. But then, instead of those primitive test automation tools, the next generation tools were using not the coordinates, but the elements in the DOM structure. Like the elements were defined by locators or the selectors. Like you can pass the type of the element, like it can be an input or button type element, and you can pass some other attributes, like you can pass the ID or something else. But even that one, it is already better than the primitive approaches, but still very problematic, right? Because most of the time the developers are changing the layout of the page, so all your DOM structure is already broken. Like you can pass the class path or the relative location or of your element, but whenever they just move slightly the elements on the page, because sometimes they are doing some A/B testing activities and they can replace the elements on the page, right? Whenever they do this kind of changes on the layout, your code is broken. So what can we do? Instead of all these kind of traditional methods, what we can do is even don't use the locator. Just describe what element you are looking for. For example, I'm looking for a button with add to basket text, for example. I just describe it verbally, right? So this is just again an NLP. Or I can just describe what kind of icon I'm looking for, and then the model that I built might try to visually find the item. For example, I'm looking for a basket icon, which can be used for an online shopping cart. Then, whenever I tell you a basket for shopping application, you might already visualize something in your mind, right? So this is exactly what happens in the machine learning model as well. So it might try to relate to the trained data. Of course, we need some different images for the basket icons. But after training this model with all these images, then it might try to find the most similar one on screen. So in this way, whenever we try to find them visually, even if all the DOM is changed, still no problem, right? Because I'm trying to find it visually. So you can do whatever you want in the back of the scenes. So this is one example of training such a model. So I'm passing different versions of a shopping cart icon. So whenever you have one similar of one of these, then I will already detect that as the icon that I'm looking for, because I already trained my model by including all these possible or potential versions. And this is from an open repository. You can just go and check. It is called as test.ai. When you go to test.ai, you can publicly see this repository. Moving on, again, I'm sharing some more examples. For example, this is now we are in the execution stage. We complete our implementation. Now we can do our execution. So how can we use machine learning during the execution? We can collect several metrics, right? For example, execution duration. Whenever I do my execution, after a number of times of execution, I can collect the execution duration. For example, one test case can take in average 30 seconds, for example. So if I learn this, if I observe this, and if in one of the next executions, if it is taking not 30 seconds, but 2 minutes, then in terms of machine learning terminology, it's an outlier for me, right? Because normally I was expecting something around 30 seconds, but this time it is 2 minutes. So the model can already notify me, then there is something here. Please go and check. So there might be an anomaly in the services that I have in my product. So maybe some of them are not responding properly or not responding on correct time. So I can just go and check. So instead of manually continuously tracking all these executions, I can set up this model and it can already notify me automatically, which will already fasten my processes, right? I can already do the same activities with way less effort and resources. Moving on. So the last stage was the maintenance. After we implement, execute, maybe we can do the refactoring of the code. So one type of maintenance activities is doing the code reviews. For example, after checking all the best coding practices or similarly the anti-practices that I want to avoid, then I can do the relevant refactoring activities. So somehow, if I can teach machine learning algorithms, the uh, good practices that I want to follow or the anti-practices that I want to avoid, then I can already let it run and it can try to detect the anomalies that I want to avoid in my framework. And self-healing is another type of maintenance activity that whenever a test case is failing, then it can try to list the potential solutions. So first of all, it can try to detect all the similar previous failures, and on top of the previous solutions, it can try to generate a potential solution for this specific test failure. So it's called as self-healing. So the test fails, but it already gives me some solution ideas. It will be kind of self-healing. And migration is another type. Like if I want to migrate my code from one programming language to another one, or from one framework to another one, again, I can just ask these platforms to do the migration for me. And finally, I want to share my case study, which I applied in my project. Because again, it is not only using ChatGPT, right? As I told beginning, using machine learning does not equal to asking questions to ChatGPT. You can develop your own custom algorithm or custom application where you can develop some machine learning algorithms. So this is a super simple one, but I will show you just to give you an idea about what you can do. For example, in this study, I try to classify the bugs. So bugs are reported on issue tracking system. In our case, it was Jira, and I just exported all these previously reported bugs. So uh, actually, it was not a huge data set. Normally, in a real actual application, of course, we need way wider data set. But in this one, I wanted to use the real data from the production environment. So I had almost not 900 tickets, and I exported them. And over that, I had three different severity levels, like high, medium, and low. Let's suppose like that. And my aim is, after analyzing all these, because these previously reported has the descriptions, and we already marked them as high, medium, or low, right? We already know that severity levels. So after analyzing this, after doing this study, for an upcoming bug, I will have the description, and the label will be predicted by the system. So this is our problem. This is a task. So let's see how we can build this system. So first, of course, whenever I extract the tickets from Jira, it will be extracted into an Excel spreadsheet. So I will have just some text, some string values. So the first step I do is just pre-processing, like cleaning the data. Like I remove the punctuation because commas, dots, or similar punctuation is not important in terms of the context, right? In terms of the meaning. I mean, it might be important, but in this case, it might be removed. So I just do the cleaning, and then there are some other irrelevant data, like the text coming from the HTML queries or the responses. So all this kind of thing, cleanings are the pre-processing step for me. This is the first step, and then after doing this cleaning, the second step is the feature extraction, like from strings, from text values, I have to extract some numeric arrays, numeric values. So this is called as the feature extraction. So there are different ways to do that. But what I followed in the study is counting the words in each sentence. Like, for example, I have a sentence, and like this word is happening two times in the sentence, or the other word is happening only one time in the sentence. So I just count. I just measure the frequency of these words in each sentence. So this is called as bag of words, BOW. And with this method, I just have the numeric values, right, for each word. So I can just convert this string into a binary number, which is called, I might already have the features. And after I have the features, the next step is the classification. So for classification, we can follow different approaches like KNN, naive Bayes, K-means clustering. All these algorithms are some different examples. And after that, we can just perform or measure the performance of our model. So for that, for example, I did, uh, after I do the classification, I check the accuracy rates. So this is the confusion matrix. And initially, I had 73% accuracy. It was okay because it is a difficult problem, right? Even for ourselves, sometimes whenever we discuss the severity of the bugs, for some people it is high severity, but for some other people it is medium, right? So it is a difficult problem even for ourselves. So for a machine learning, it is not really easy to align with the previous results. But there was still one improvement point that I could do, because let me a little bit go back. Because in this case, there were three different severity levels, but most of them, most of the examples that I had, was clustered around one of the classes, which means there was a bias on one of the classes. So I tried to eliminate this bias. So I tried to combine 3 and 4, which are the medium and the low priority levels. What is the meaning of that? It made sense for me, because for me in my system, if bug has the high severity level, then it was a release blocker. But if it is medium or low, it is not. So medium or low means I can combine medium or low, these two together, and decide if I have a high priority or not. Or not means the others, 2, 3, and 4. So after combining this 3 and 4, the bias was removed, the distribution was more balanced, and this time I had the 82% accuracy. Again, it is arguable, like maybe I cannot directly use the results coming from this algorithm, but I can already do the first classification by letting machines run, right? And then after getting the responses, I can just do some slight modifications. So this already helps me to reduce the time that I'm spending on classifying these bugs. And not only the classification, but also I can do the clustering too, to group similar bugs together. So I can assign to same teams or maybe the same members in different teams. So I'm wrapping up. We discussed using machine learning in different stages of software testing, which starts by analyzing the requirements and then implementing the test code, automating the test code, and finally doing the maintenance activities, but which might be refactoring the code or maybe trying to build some self-healing algorithms, or maybe just managing the bugs by doing some classification or clustering algorithms. And the final discussion, like in the future, will we lose jobs? Should we be afraid of losing our jobs to machines or robots? So my question would be, if you have two options, like hiring a person who does not have a PC, just doing all the tasks manually, this is the first option, or your second option would be having a PC where you don't have a person to operate it. So these are the two options. Which one would you choose? Of course, you would choose a PC with a person, right? You would choose a collaboration. So why are we trying to compete these two, but not try to make some collaborations between machine learning algorithms and the manual activities that we have to complete in our projects? So thanks a lot for listening to me. And if there are any questions, I will try to answer them now.
That was an amazing session, Mesut. Thank you so much. At the moment, we don't have a question Q&A. For those attending, feel free to ask a question if you have something on mind. Otherwise, again, he's put his contact details here on this slide. So again, I'm pretty sure you're open to questions outside of the chat itself. But no, this was a really valuable session. So I'm just going to give another second or two to see if any questions going to pop up in the chat. And if not, I guess we are good to wrap up. If there's anything else you want to end on, if you felt rushed and there was a closing note you wanted to add, feel free. You have.
Thank you so much, Nigel, for the moderation. It was great. And it was my pleasure to be here. Thanks.
No, amazing. So look, with that, I guess we'll wrap up. Thank you again for the session. I'm just going to put in the closing conclusion part. So thanks again.
Thank you.